and log in. And I just want to walk through a few things really quick, so that way we can get going. Okay. So we've got your course right here. And when you walk through this course, you're going to see sampling and confidence intervals and hypothesis testing. I guess it's a little, let's see here. Hopefully you're getting good visual of all this, and it's not just, if the picture's sporadic, if you guys can tell me if there's something wrong with the picture or the video, just let me know. So I'm going to click on the confidence intervals right now. And when you click on the confidence interval, you'll be able to download the textbook. You'll be able to get the answers to the odds in the back of the book. You're going to see the syllabus, individual quizzes, and then the practice exam, which is a really good metric of the actual exam. And then if you click on Chapter 8, you will see, okay, we've got a video that goes over sampling methods, sampling distributions, point estimates, and confidence intervals. And also, if you guys already watched some of the videos, if you have questions, if you want to type your questions into the chat, I'll answer your questions as I go through this YouTube Live. So that's one of the benefits of being on YouTube Live, is I will answer your questions for you if you put them into this fun little chat thing. This is my first time doing this, so bear with me. So let's take a look. We've got Chapter 8, Chapter 9, then you've got the PowerPoints. You should be able to access everything, the quizzes, and the printable resources. So what I want to do right now is actually go through some of the printable resources, because I don't actually have a video to go over the printable resources. So I'm going to start there and make sure that you know what it is that you're looking at. So if you look at the population versus sample distribution right here, it's really cool because we are actually right now, we are shifting from, we were going over population distributions, right? So with a population distribution, you have an entire distribution of the entire population, and each and every single observation that's here is representative of a single observation. But now, when we have this distribution, we no longer are representative of a single observation. What the representation is, all these different observations, they're actually entire groups or samples, if you will. And so this fun little sheet right here, if you look on the left-hand side is talking about a population distribution, and the right-hand side is talking about a sampling distribution. So this is a really good resource for you to understand the difference between a population distribution and a sampling distribution of sample means. And so I'll go over that in just a little bit. Then the Chapter 8 through 9 sampling and confidence intervals PDF. I'm going to open this up. And this is just the, all the formulas that you're going to be using for Chapter 8 and 9. So if you take a look through this, it gives, just like the previous ones, it gives you the terms, it gives you, the formulas that go along with everything, how to calculate margin of error, so on and so forth. So there's a lot of really good information in here, so make sure that you know how to navigate that. And then this right here is a really good resource for helping you to make a decision. What I clicked on there is the Chapter 9 confidence interval decision tree. And so this helps you to know, hey, what is it that I should be looking at? It says step by step, should I be looking at a confidence interval around a proportion, around a mean? Do I know the population standard deviation? Do I not know the population standard deviation? So on and so forth. And so this right here is a resource just to help you to make a good decision as you're navigating the everything. And then a little bit later in Chapter 9, we're going to be using this resource as well. And so just be aware that these resources are here for you, and just like what I would give in class, you can download those and print them out. Okay. Let's keep moving. So Sampling methods and the central limit theorem. It's really important to know about sampling methods and the central limit theorem, because with sampling methods, we basically know who it is that we're looking at, right? For instance, right now, I have a survey going out to all of you all that specifically asks, how are you guys feeling about the semester? The problem with that is that almost everyone in that survey, or the majority of individuals in that survey, are from the business school. And so while I put this survey out, the individuals that are represented, I can't say, hey, this is a survey of Baylor students. I have to say that this is a survey that is representative of primarily business students. And I also have this composition of these other students, but I do have a survey, and it is representative of some of the business students. And so that's why we've got to really make sure that we've got good sampling methods. And so what I used is a really poor sampling method, and it's referred to as a convenient sample. It's so poor that I'm not even going to be, covering it in this lecture. But with convenience sampling, you literally are taking the most convenient sample, the most convenient sample to be able to sample whoever it is that's accessible to you. Definitely not the best, but it gets the job done, and it gets you started. Another thing that I said, when I was I wrote it down while I was getting approval to make sure that it was okay to do this sampling and to survey everyone, is I specifically said, I'm going to oversample in this one particular area to begin with the understanding that it will be oversampled, and hopefully we will get more people from outside that sample in the future. But that's it's really important to know who you're sampling and what your sample represents. So once again, there's lots of reasons to make sure that you are sampling. Samples. So samples are used for lots of different reasons. For instance, if I were to take a sample and I want to make sure, like for instance, I make rope, and if I want to make sure that my rope is what it says that it is, if I say that my rope can hold 100 pounds, then I've got to test that rope, and I've got to put a 100-pound weight on the end of my rope. And so I'm going to put a 100-pound weight on the end of my rope, and I'm going to test it. And not only am I going to test that, I'm going to keep pulling on it until it breaks and snaps, and then bada bing, bada boom, I know at 200 pounds my rope is going to break. I can't test that rope over and over and over again, because if I were to do that, it would destroy the entire population. It would destroy every single piece of rope that I have. So it's really important to make sure that we only sample a part of it. So I'll take every so many samples, I'll take that, and I'll be like, hey, you know what, I'm going to sample every 200th line of rope, or every 200th foot. If I make spools of rope that are 200 feet, I'm going to run a spool of rope, or like 20 spools of rope, and then I'm going to take the 20th or the 30th spool of rope, and I'm going to test that one. So you just have to know this is what I'm doing to make sure that you don't destroy the entire population. Also, it's very expensive to study the entire population. So we run the census, but we only run the census once every 10 years. And one of the reasons why is because it's extremely expensive. And so we're running the census right now, and it surveys everyone, but it's a really big deal to survey everyone. Let's see here. Also, it's very time consuming. For instance, if I want to know how students are doing, I can't sit there and survey every single person, because it's going to take forever to survey every single person. And then another thing, it may be impossible to check or locate it may be difficult to check or locate, the entire population. Like for instance, if I'm want to know the water quality in Lake Michigan, I'm going to, take a jar of water or a beaker of water from different locations, but I can't drain the entire lake in order to check the quality of the water. I can only check certain locations, and I just take small samples from that. So those are different reasons to sample. Now, I'm not going to cover every single one of these in the same depth as what I would in the video, because you do have the video, but I'd encourage you to look at the video and watch that, and definitely send me your questions about that. But we have 4 different sampling methods. Also, make sure that you pay attention. A lot of people on the exam questions, and when you come and you listen to my fun little live lecture, I'll tell you, different hints and tidbits. Like for instance, you're probably going to see a question on the exam that asks, what is a reason not for sampling? A reason why you don't sample, or a reason why you would sample. And what people get tripped up all the time on, they always forget that sampling will destroy the entire population. And so you might see that on the exam. Why would you run a sample? And the reason why you would run a sample is because if you survey the entire population, you would destroy the entire population in some instances. So we have right here 4 different ways to sample. Now the sampling methods, these are just 4 ways that you could sample. These are really good ways of sampling, but the ways that are normally sampled, especially in human research, don't normally follow these the way that we want it to. For instance, in the study that I'm doing with you guys right now, where I'm sampling you, like I said, I'm doing a convenience sample, and then after that I'm doing what's called a snowball sample. And so the convenience sample is I ask all of you guys who are very conveniently connected to me, and then after that I say, and if you wouldn't mind, just go ahead and share that with your friends, so that way they can complete it too, and that's called snowballing. I don't know if you guys have ever made a snowball, but when you push a snowball, or when you push a snowball to make a snowman, you push it and then it hits the next person, and then the next person, and then eventually it just gets bigger and bigger, and then everyone just keeps on compacting, and it gets bigger and bigger as more and more people share the survey. And that's why it's called snowball sampling, is because it's just basically everyone shares it with everyone. And it's a horrible way to do it, but at the same time it gets the job done as long as you are very transparent with how you did it. And the reason why it's a really bad way to do it is because think about who you're connected to. If you survey, or if you share your survey with other people that are connected to you, are they going to be pretty much the exact same as you? Yeah, they're going to be very similar. They're going to be your friends, people that are like you. And so, when you do snowball sampling, it basically is just finding more people like you. So when I ask you to share it with your friends, you're probably going to share it with more business students that are right around sophomores. So yeah. So these are the 4 different sampling methods. And if you guys have any questions, like I said, feel free to ask questions right here. Here, I'm going to type, please ask questions. Ask questions. Tell me what you want me to go over. There we go. Simple random samples, systematic random samples, stratified samples, and cluster sampling. Simple is the easiest one. Okay, and I'm going to show you guys, the book tells you how to do a simple random sample. I'm going to show you guys how to do, hold on. I'm going to show you guys how to do file, new. There we go. I'm going to show you how to do it even easier. And so when you do this on your project for your homework, it says do the do this random sampling thing. And so this is what you do: equals rand between. Okay, so say for instance you have 100 people. Okay, you have 100 people, and you're going to put their names right here. We're going to put person 1, person 2, and then we're going to go all the way down to 100, or 178. Okay? So what we're going to do now is, say for instance, I want to randomly select between these 178 people. So say for instance, I don't know, what's something that has 178 people in it? You know, let's just say the people enrolled in QBA 2 this semester. So there's 178 people enrolled in QBA 2 this semester. And so I'm going to go like this, and I'm going to say equals rand between, and I'm going to put 1, comma 178, and then I'm going to press enter. And it gives me 87. Okay, so 87 is you know, between 1 and 178, and if I double click again, 112. Okay, so here's what I'm going to do. I want the first 4 people, no, the first 3 people that write their names in the comments. I'm going to put their names up here and randomly select one person to get extra credit. Okay, so we've got to wait for 3 people. So we're going to put person 1, person 2, person 3, and I'm going to wait for the first 3 people to put their names right here to see if I can give them some extra credit. Let's see here. I guess no one's here. Well, we'll just keep on moving on. And so we've got the random between. So the random between, if I were to do that, we're going to hold on, equals rand between. Also, we got John, we got Hunter, and then do we have a third person? No third person, so we're sticking with just those 2. So we're going to do equals rand between. We're going to put 1, comma, and 178. And John gets anything in the lower half, and Hunter gets anything in the upper half. So, and you will get I don't know, let's just say 3 points of extra credit if you get the random number. Okay. 116. So that's going to be Hunter. And just because I appreciate you, John, I'm going to give you one more shot. I'm going to double click and rand between, so both John and Hunter get 3 points of extra credit. I'll add that to you, and so hopefully more people will tune in because they know that they can get extra credit if they tune in while I'm doing my live chat. So that's the rand between for simple random sampling. Literally, simple random sampling is just sampling someone just randomly, just a random number. Okay. A sample selected that each item or person in the population has the exact same chance of being selected. Let's see here. For instance, there's 750 Major League Baseball players at the end of the 2016 season. A committee of 10 players needs to be formed and studied based on concussions. So let's take a look at that, what we would do for this. I'm going to go right here. And so let's just say we've got... we're going to do this same thing, except we're going to do 750. Okay, and I'm going to do 10 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so now we're going to choose these 10 people. And if you get a duplicate, you just hit it again, and then you take the next person that's not a duplicate. So you associate their names between 1 and 750. Oh, you're late. Should I add him on? Let's see here. I'll think about it. So between 1 and 10. And then so you would choose the names that are associated with these numbers going down the side. So that's simple random sampling. There's a way to do it with this fun little book with random numbers, but you're never going to do it. So if you want to read about that, you can. The book tells you to do it, but I'm okay with you just doing it the way that I said you can do it right here. Systematic random sampling. This is when you take a random starting point, and then every so many persons you in the pot you select. Like for instance, when you want to know who's coming into a grocery store at a particular time throughout the day. This is really good to say, okay, we're going to take every 20th person that comes into to the grocery store, or every 20th person that comes into the ballpark, or every 10th person that visits our website. Because the truth of the matter is people that come at 9 o'clock or people that come at 8 o'clock in the morning are going to be different than individuals who come at 2 a.m. I mean, because have you guys ever been to Walmart at 2 a.m.? It's a little freaky. But the individuals that come at like Sunday afternoon at 3 o'clock, after church, it's like, okay, they're not quite as freaky. They're just crazy. And so, it's really important to know you get a good spread of the individuals that are coming into a certain location at a particular time. So it says, okay, we're going to start at a particular time. We're going to take every so many person after that. And then stratified random sample, a population is divided into subgroups called strata. This is, for instance, you guys have this situation when we are dealing with our data. We did frequency distributions, right? And when we did frequency distributions, we were able to say, okay, we've got this frequency distribution. Let me make a frequency distribution really quick. Does anyone have anything that they want me to go over yet? So frequency distribution. So say for instance, we're going to have, I don't know, let's do this again. And I'm going to make a frequency distribution really quick. Insert, and so I've got this fun little frequency, this is a histogram. And so if I look at this, I'm going to say, okay, I have 21 people from here, 20 people in this one, 19 people in this one, and I also have 20 people in this group, but in this far group, I only have 5 people. Should I survey all 5 of these groups equally, or should I break these up differently? So what I want to do when I'm doing stratified random samples, I've got 5 different strata that these are broken up into, and so I'm going to take a certain number from these 4, but this one down here, I'm not going to take the same number. So say for instance, I only want to survey 20% or 10% of the population. I might take 2 from this group, 2 from this group, 2 from this group, 2 from this group, and then just 1 from this group. And the reason why they keep changing is because every time that you click, you get a different random number. And so, but you take a representative sample from each group. So you say, okay, I'm only going to take 20% from each group, or I'm only going to take 10% from each group. And we deal with this all the time. Like for instance, if you have companies, and you've got companies that make between 1 mil or below 1 mil, 1 to 2 mil, 2 to 3 mil, then 4 mil or higher profit in a year. So you might have 2,000, and then you might have 1,500, 1,200, and then you have 4 million or higher, and you might only have 30. You would take a representative sample of each one, and so what you could do is if you want to say, hey, I only want to take a total of 200, then what you would do is you'd say, okay, what is the relative frequency to the whole? And so you do equals sum. You add all of these up. You add all of those up, and then you do equals this divided by 4730 equals this divided by, and then equals this divided by, then equals this divided by. Okay, and so you get all of that wonderful stuff, and then you do equals this multiplied by 200, and then I am going to just drag it down. And so this is the samples that you should take first. Whoops. I accidentally put the wrong $sign. You should take this many from each one. Okay, so yeah, I really appreciate John saying, hey, can you go over number 16 or 18 in the homework? And the truth of the matter is I have absolutely no clue what these videos will be good for. Because I already give you guys some videos online, and I certainly don't want to waste your time. So if you guys want to go over homework, I can definitely use these videos to go over some homework questions, homework problems. So John, I appreciate you asking me about that. And so I'm gonna pull that up really quick and see what chapter 16 and 17 is, or question 16 and 17. So I'm going to go to vital source. And hopefully you guys will see how beneficial it is to tune in live, because you get your questions answered. Okay, so while that's logging in, we're going to go over cluster sampling really quick. Cluster sampling is when groups are already formed into clusters. So if you think about it, stratified random sampling is really when groups are broken up by quantitative data, where cluster sampling is when groups are broken up by qualitative boundaries. So these are broken up by qualitative boundaries, where the quantitative or the stratified random sampling is broken up by quantitative boundaries. So when you've got clusters, when you've got groups, qualitative groups already broken up, then you take them, you take your sample, you take a certain selection from each group. Okay, so I'm pulling up my my book right now. Okay, so that is cluster sampling. So for instance, if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different counties, the majority of individuals live in Cook County. The reason why is this is where Chicago is. So that's where Chicago is. And so if we were to just randomly select people, like 95% of the individuals that live in this area live in Cook County. And so it really wouldn't be beneficial to, just randomly select people, because 95% would be in Cook County. 95% of the sample would be from Cook County. And so it's really good to say, okay, we're going to take 10 people from Lake, 10 people from McHenry, 10 people from Kane, 10 people from DuPage, whatever, DuPage. I don't know, Grundy, Will, Cook, Lake, and just take 10 people from each one, so that way you get a good representation from each county. So let's see here, exercises number 16 and 17. Okay, so let's take a look at this. We've got 16 and 17. And if you guys have other questions, let me know and I will go over them. Okay, so let's look at 16 and 17. So this is chapter 8, sampling distributions. A normal population has a mean of 75. Is this right? Okay, yes. So a normal population has a mean of 75 with a standard deviation of 5. You select a sample of 40, compute the probability the sample mean is less than 74, between 74 and 76, between 76 and 77, and greater than 77. So what is it that you should be pulling up to help with this? Like I said, you guys have all the videos, you have everything that you need to succeed. You really don't need too much more from me, but I do feel like this is a really good use of our time. Sorry, let me just get rid of some of this stuff. Really good use of our time to go over some questions that you have. So I'm going to put this right over here, and I am going to escape. There's my son. So we have, let me pull this up. You have the, let's see here. You have the Unit 3 sampling and confidence intervals, the population versus sampling distribution, and let me pull that up again and open this up. So let me make this bigger. Remember previously, before the wonderful break, we would have a sample mean and a population mean. Okay, and then we also had standard deviations, and we had so we had standard deviations, and we were able to use the normal distribution to be able to say, hey, this many observations are within this many standard deviations. This many observations are within this many standard deviations, so on and so forth. Okay, so it's a little bit different now. And I've got to pull this back up. So it's a little bit different now because we are no longer dealing with individual observations. We are dealing with groups, okay? And there's a lot of differences. When you are dealing with groups, there's a lot of things that happen. The groups actually, when you have a group, you have a whole group of, like, say 10 people, and that group of 10 people will have a mean. For example, if I take groups of 10 of people's heights, okay, for instance, let's do this. So we've got all these we've got all these individuals, and their heights are anywhere between 60 inches all the way up to, I don't know, let's say 72 inches. Okay, so we're going to do equals rand between equals rand between 62 and 70. Okay, and so I've got, and I'm going to drag this down, and let's say that I've got these 10 people. Okay, and so I've got these 10 people, and if I were to ask you, hey, what's the probability that a individual will have, actually let's broaden this out a little bit. Let's go 53 and 76. Okay, 53 and 76. You know, if I were to say, what is the probability that an individual's height will be below a certain amount? Well, right here, let's see, between 53 and 76, and let's make it normal. And there's actually this fun little tool that I have, I'm going to do something really quick. This is kind of fun. So I've got a mean. I'm going to say that the average height is going to be 65. Yeah, that sounds about right. Oh, that's annoying. Thank you. You don't need to see me anyway. So hopefully transition. There we go. Is that better? All right. So I've got this. Let's see here. I'm going to have a mean of 65 with standard deviation of 5, and I'm going to have a min of let's see here, 52, and a max of 78. With bin sizes of 3. Okay, so I'm going to copy these, and I'm going to have 40. Okay, so I just use this fun little tool that I have that randomly selects numbers and does it in a perfectly normal distribution. And so if I were to say to you, what is the probability that one particular person what is the probability that one particular person is going to be below a particular point? And so you can use the normal probability distribution to do that. And you can use that formula, the normal probability distribution formula, where you find the z-score and you use the z-score to be able to see how far away that is from the mean, and then compare the z-score to the z table. So we're going to do something very similar. So this right here is the formula for that. So if I were to say, for instance, what is the probability that one particular person is going to have a height below 68 inches? So I'm going to do equals average. Okay, so I've got the average right here. And the average is 65.0175. Then I'm going to do equals standard deviation. Okay. And so then I've got 4.159. And so if I want to find the z-score, I would do equals. So for instance, if I want to find the z-score of an individual having a height below 58 inches, I would do equals 58 minus 65.075. And then I would divide that by the standard deviation, and that would give me the z-score. So I would have a z-score of negative 1.709. And then I would find my handy dandy nifty z-score chart that I gave you guys. You can also get it. I'm going to let's see here. Z-score, z-chart. So I've got the z-chart. I need to make sure that I have this. I'm pretty confident I have it up in Canvas. So I've got this z-chart right here, and I find the z-score of negative 1.7009, and so I come down here and I say negative 1.7009. Well, that's right here. So this right here, this is the probability. So in other words, 4.46% or 0.0046 is the probability of it being below of an individual having a height below, so 0.04, let's see here, 0.0446 is the prob of having a height below 58 inches, of one person having a height below 58 inches. Okay. So that right there is a single observation compared to the whole. Now, what's different is when we take a group of, say, 10. Okay, so is this 10? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I take a sample of 10, and let's just say we're going to take this sample right here of 10, and I want to know how does this group of 10 compare to the whole. Okay, so we're going to use a slightly different formula. We're going to come over here, and over here we're going to still find z calculated, but instead of finding z calculated for an individual, we're finding z calculated for a sample. So z calculated for a sample compared to every other possible sample of 10. Okay, so let's think about this for a second. We use this fun little combination formula, right? How many possible samples of 10 are there? How many possible samples of 10 are there? So we're going to do equals combination. Okay, and there are a total of, let's see here. I think I don't know. Let me find how many I selected. So there's 40. So equals combination 40. And we're choosing 10 at a time. And if I do that, there are these many different possible samples. Okay, that's a lot. I don't know, let's see here. That's 847,660,528. So what we're doing is we're saying we are going to take one sample of 10 and we are going to compare it to every other possible sample of 10 that could possibly be taken from that population of 40. Okay? So we are going we're going to take one sample of 10 and compare it to every single other population sample, every other possible sample from this population of 40 observations. Okay, and so that's what this does right here. And when you do this, the larger your samples get, the narrower the distribution becomes. And so it's really important to know that, and even more accurate your estimations become. And so I'm going to go ahead and do that right now with this particular example. So you see this formula right here, and I'm going to zoom in on that a little bit. So we've got this formula right here. We're still going to calculate the z-score. And so I'm going to do equals average. And I'm going to take the average of these first 10 numbers. I'm just going to say that these were my randomly selected numbers. So average of this divided by the population average, or sorry, not divided by, I'm so sorry, minus the population mean. And then I'm going to put those in parentheses. And then I'm going to divide it by the population standard deviation. And I'm going to put these in parentheses as well. And then I'm going to divide this by the square root of the total number of observations in the sample. Okay. Square root of 10. Okay. So let's go ahead and press enter. So in order to do this, and I'm just going to put this off to the side for a second. These were the things that we needed. We needed x bar, then we needed mu, then we needed, actually, this is mu, then we needed the standard deviation, and then we also needed sample size. So x bar equals average. Okay, so 66.1, and then mu is 65.075, and then standard deviation is 4.175, and then sample size is 10. So we did that, and we found that we have a z-score of 0.779. So we come over to this fun little z-chart, and we're going to zoom in a little bit, and we're going to find 0.779. 0.7, okay. And then we're going to go all the way down here. Let's see here. Right here. Let's find the intersection. So we've got 0.7 right here. And it's kind of hard to do this on a screen. And then 0.7 right here. 0.77, it really is closer to 0.778. So 0.779 or 0.78. So this right here is the probability of an individual or a group of 10. This right here is the probability of a group of 10 having an average height of, okay, let's see here. Let's see, 9, 8, this right here is the probability, so 0.2177 is the p of a group of 10 randomly having a average height of 66.1 or higher. Okay, so let's take a look at your actual question on the homework. Okay, vital source. Okay, A normal probability, a normal population has a mean of 75 and a standard deviation of 5. Okay, a mean of 75. So let's do this. We've got a mean of 75. Then we have a standard deviation of 5. And then our sample size is 40. And then what do we have for x bar? Okay, so the first one that we have is 74. So we're going to do the same exact thing, same formula. And let's pull this up. Okay. Sorry, wrong one. So we've got this formula right here. So we're going to do equals, put these in parentheses, minus mu, close parentheses, divided by standard deviation, divided by square root of the sample size. And that gives us a z-score of negative 1.265, okay? Negative 1.265. So I go to the z-chart, and I find negative 1.26. Okay, so we're going to find 6, which is right there. So negative 1.26. And so the probability of 0.1056 is the probability of, what is the question asking again? Probability of a sample of 40 having a mean of 74 or less compared to all other samples of 40. Okay. And then between 74 and 76, this is actually really straightforward. And there's a really easy way to do this. Because 74 is 1 below 75, and 76 is 1 above 75, and those are the means. The way that you can do this is literally equals 1 minus 2 multiplied by 0.1056. Okay, and the reason why is the probability of a sample of 40 being below 74 is the exact same as the probability of a sample being above 76. And so we've got below 74 is 0.1056, above 76 is also 0.1056, and so the total probability is 1, so 1 minus the two of those is 0.7888. Okay, so this right here is A, B, let's do C, and then we'll do D. So C is between 76 and 77. Okay, so now we know above 76 is 0.1056. Now all that we've got to do is find above 77. So let's do that. So greater than 77. Let's do that first. Let's do D. So we're going to find above 77. So let's X bar 77. Notice I had my fun little formulas in there, and because I had my fun little formulas in there, it automatically updated it to having a z-value of 2.53. 2.53 is our new z-value, so I'm going to go to the z-value, which I'll just run through it again. Just I don't know. Should I run? I guess I'll run through it again. Equals. Let's look at the. Okay, so we've got this right here, equals x bar minus mu, in parentheses, divided by, in in parentheses, standard deviation divided by square root of the sample size, and it gives us 2.53. And so let's go to the z-chart, and we're going to say 2.53, 2.53, which is 0.0057. Make sure that you go, this right here is 0, so go 0, 1, 2, 3. Okay, so above 77 is 0.0057, and then between 76 and 77 is going to be equals 0.1056 minus 0.0057, okay, which is 0.00999 repeating, okay? So negative 1.26. What did I say? Let's see here. Yes. Let me look at something really quick. 74. Why did I do what I did? That's a good question. Why did I do 5? I did 5.5 instead of 5.6. Or negative 1.26. I think I was off when I scrolled down. So negative 1.26. Yes. Oh, pa. So it's supposed to be 0.1038. I apologize, guys. It's just, yeah, a little hard to see on this fun screen with everything zoomed in. So I apologize for that. So this is going to be minus 2 times 1.038. Thank you for that catch. And then D is going to be, D is fine. And C is going to be 1.038. Right. Yep. So it's going to be 0.0981. So that pretty much messed up everything. But thank you, John, for that catch. So that way we could fix that. So that's how we do number 16. I'm assuming that number 18 is very similar. Let me take a look at number 18. That's not it. Vital source. Give me a second. There we go. Number 18. According to the IRS study, it takes a mean of 330 minutes for taxpayers to prepare, copy, and electronically file a 1040 tax form. The distribution of time allows for the normal distribution of the standard deviation is 80 minutes. A consumer watchdog agency selects a random sample of 40 taxpayers. Okay. What's the standard error of the mean in this example? So let's scroll down. Once again, let's go to our fun little sheets that we have downloaded. No, better yet, let's do this. Okay, so we've got 18. What is the standard error? So let's, I'm going to exit out of that. I'm going to scroll out, zoom out. That's not the one I want. Nope. Oh. Nope. That's for confidence intervals. So let's take a look at this. Standard, you've got the sampling error and the standard error. Okay, sampling error, which is in my lectures, it basically says this is the difference between the mean of a sample and the mean of a population. Okay, but a standard error is on average, how far away is each sample mean from the sampling distribution. Okay, so equals right here we've got sorry, we've got to find the standard deviation, and we've got to, so standard deviation is, and then we also have number of, or just n, equals. So let's go right back here, and so it says the standard deviation, a mean of 330 minutes, 330 is the mean, okay? So, and this is pop mean. Okay, for taxpayers to prepare a copy and electronically file 1040. The distribution of time follows a normal distribution and the standard deviation of 80 minutes. Okay, a consumer watchdog agency selects a random sample of 40. And so now we need to determine what the what the standard what the sampling standard error is. And standard error is, like I said, the exact same thing as the standard deviation. It's just dealing now with grouped data instead of individual data. So we take the equals the standard deviation divided by the square root of the number in the sample, and that's going to be 12.6491. So let's look at this. So this right here is the, what is the standard error? And so that's going to be 18. We'll do A. And then let's do B. What is the likelihood that the sample mean is greater than 320 minutes? Same thing as what we did before, right? So we're going to have the X bar is going to be 320. What's the probability that it's going to be greater than 320? So now what we're going to do is, let's go back here and zoom in for the Z calc. And we're going to do X bar equals X bar X bar minus mu, or the population, divided by the in parentheses standard deviation divided by the square root of the number in the sample, and that's going to give us, this is the z-score. So this is not the probability, but this is the z-score. So let's find this really quick. We need to go to the, let's see here. Here we go. We've got the z-chart right here. So this is the z-score. So let's go to negative 0.7 and then go all the way down to the end. So, sorry, negative 0.7, go all the way down to the end, negative 0.79. Okay, so what we see here is 0.2148. Now, what does the question ask, though? The question, make sure that you're paying attention to this. The question specifically asks, what's the likelihood that sample mean is greater than 320 minutes? This right here is the probability that it is less than, or the likelihood that it's less than. So what we're going to have to use, P of less than 320 for a group of 40. What we're going to have to do is equals 1 minus this, and that's going to give us 0.7852. And then between 320 and 350, once again, you know, we're using that fun little rule where 320, let's see here, the average is so this is 10 below and then 20 above, so we're gonna have to do a little bit of calculations. So in order to find the best way to do this is to say, hey, what's the probability of it being between 320 and the mean? So I'm going to do that first. So it's going to be equals 0.5 minus 0.2148. And so 0.5 is the probability of an individual having, or the probability of a group of 40 having an average of 330 or below. Okay, so 0.5 is the probability of a group of 40 having an average of 330 minutes or below. And so if I take the average of 330 minutes or below and subtract from it the probability of 320 minutes or below, in other words, let me make a visual. Okay, these are all of the individuals that are 330 minutes or below. These are the individuals that are 330 minutes or above. So this right here is 330 minutes, 330. Okay, and this is the mean. Let's do this: 0, 1, 2, 3, and then -1, -2, and -3. And so if I were to say, hey, what's the probability of from here or below, it's going to be a 0.5 probability. In other words, half the individuals are going to be at the mean or below. Okay, but if I say, let's just say 320 is right here, which isn't exactly right. But if I were to say, hey, what's the probability of an individual being between the mean and 320? What I have to do is I have to take 0.79 is what that is. Or sorry, not 0.79. 0.2148 is the probability of it being 320 or below. And then this right here is 0.5. So if I take 0.5, which this is 0.5, and then this right here is 0.2148, and I subtract 0.5 from if I subtract 0.2148 from 0.5, it gives me this little bit that's left, which is going to be equals this minus this, which equals 0.2852. Okay, and so now I also need to know, we've got 350. What is the probability of 350? Hey, bug. Oh, I see it. That looks great, bud. Cool. Sorry, my son was just saying hi. 350 or above. And so in order to do that, what I really want is I want everything in this area right here. So we need to find the probability of it 350 or above, and so we can also subtract that from 0.5. So let's find the z-score of 350 and above or higher. Okay, and can everyone who's still here write your names really quick, and I'm going to give you guys some extra credit for staying until the end. 350 and above or higher. Let's see here. Sorry, I gotta find my Excel file. That's not it. Don't save. Oh, I was in my Excel file. What I need is this. So my zcalc. We are going to do x bar. So x bar, mu, standard deviation, and okay, so n is still 40. Standard deviation is, let's see here, standard deviation, I appreciate you guys. Standard deviation is still going to be 80. Mu is still going to be 330. And then x bar is going to be 350. So equals 350, or better yet, 350 minus 330 divided by standard deviation, in parentheses, divided by standard deviation, divided by the square root of n. Okay, and so that gives us 1.58. And so I'm going to come right over here. I'm going to go 1.5, go all the way down to the second to the end. So it's going to be 0.0571. 0.0571 is going to be the probability from here over, from 350 or above. And so I'm going to do equals 0.5 minus 0.0571. Okay, so that's going to be 0.4429. And so to find the probability of it being between in these two areas, you add up the area right here plus the area right here. So you do equals this plus this, and it gives you 0.7281. So that is the probability of it being between these two. So I'm going to Control C, Control, I think that this is it. This is C. Control X. There we go. C. And then D is going to be this one right here. Control C. Control V. And that should be it. So I think that's all that we're going to cover for today. That was a lot of information, a lot of going through stuff. I think what I'm going to end up doing is asking you guys beforehand which questions maybe you want me to cover. Maybe that's the best use of y'all's time, is saying, hey, we're going to do a lecture over the homework that you guys want. If you guys like that, let me